Hello viewers, I am Kausalya. Today we are going to solve problem number 4 under the topic polar plot. The problem is consider a unity feedback system having an open loop transfer function. The function is given here, and the next thing is sketch the polar plot and determine the value of k so that gain margin is 20 dB and phase margin is 30 degree. So here this is our given g of s. Here we are asked to find for what value of k the system will be having a gain margin of 20 dB, and similarly for what value of k the system will be having a phase margin of 30 degree. So here the first thing is we have to assume the value of k as 1 and we have to draw a polar plot. That is our first step. We will proceed with that. So here the polar plot is sketched by taking the value of k equal to 1. So substitute k equal to 1, and again as usual step we have to substitute s equal to j omega. So when you substitute here, our expression gets modified as g of j omega equal to 1 by j omega into 1 plus 0.5 j omega into 1 plus 4 j omega, right? So from this expression we are going to find another two expressions. One is for magnitude and another one is for phase angle. So how to find expression for magnitude? We have to square root and we have to square the elements inside. So here you see I am having j omega. So here square root of omega square. So this square root and this square cancels each other. So finally I am having omega, right? And here when you take square root of 1 square plus 0.5 omega whole square. Similarly for this one, 1 square root of 1 square plus 4 omega whole square, right? So once you solve this expression, here you will be getting 0.5 omega square is 0.25 omega square, and similarly 4 omega whole square is 16 omega square, right? So here I am having two elements. Both the elements are under the square root. So now I am going to combine these two elements. So here it is square root of 1 plus 0.25 omega square into 1 plus 16 omega square. The next step is I am going to multiply these two expressions. So once you multiply, you will be getting expression like this. Finally, I am going to simplify this expression again. So here you see I am having 2 omega square terms, right? Now I am going to add these two terms since both are with the same plus sign. So 1 plus 16.25 omega square plus 4 omega to the power 4, right? So finally this is our expression for magnitude. Now we are going to write expression for our phase angle. So this is our given problem, right? In that problem I have substituted s equal to j omega here. So how to write the expression for phase angle? As I already said, an omega in the denominator, that is contributes an angle of 90 degree either in numerator or denominator. If it is in denominator, I am going to move this expression to the numerator part, so I have included a minus here, right? And similarly, how to write expression for these terms, that is the term which contain both real and imaginary part, that is tan inverse of imaginary coefficient divided by real term. So tan inverse of what is the imaginary coefficient? It is 0.5 omega divided by the real term is 1. So tan inverse of 0.5 omega. Since this is again in denominator, I am moving to this numerator. So here again I had included minus, and similarly for this term, right? So minus tan inverse of 4 omega by 1. So this is our expression for phase, right? Then the next thing is we are going to frame a table. The next step is we are going to form a table which contains both magnitude and phase angle. So in the previous problems, I had asked you to take the corner frequencies, but here the corner frequency is not taken. If you wish, you can take corner frequencies and include those terms also, okay? Nothing is going to be wrong. So here we have taken random values of omega. You see it starts from 0.3 and up to 1.2, right? For these omega values, we have to find out what is the magnitude as well as what is the phase angle. Okay, this can be done just simply by using a calculator. We had find out the two expressions, right? So this is the expression for your phase angle. In the place of omega, you just substitute 0.3 and write down the answer here. Similarly, the next thing is for omega, substitute 0.4 and write down the respective answer. right? Likewise, you can complete this table. And similarly for magnitude, we are having an expression, right? So this is our expression for magnitude, right? So for different values of omega, just substitute it and write down the answer. This can be done simply using a calculator, okay? This is an easy task. The thing is, you have to feed the calculator with plus and minus signs properly. That's the thing, right? So now the first part is over. That is, we have drawn the polar plot for the given problem by assuming the value of k is equal to 1, right? But what we are actually asked to find, we are asked to find the value of k with a specified gain margin and phase margin. So before that, we will draw the polar plot. So this is my polar sheet, right? So the polar sheet should be always kept in such a way that your right hand side should have 0 degrees and the left hand side should have 180 degrees. Okay, it is must, right? So after placing the sheet, we have to select the values of magnitude depending upon the values which we get in the table, right? So here I had selected the values like this: 0.4, 0.8, 1.2, 1.6 and 2. Right. So after writing the scale, the thing is you have to encircle or you have to brighten the unity circle. You have to check where you are having the value as 1. So here this is my unity circle. So I had highlighted the unity circle. Right. So these are all the basic things you need to do whenever you took a polar sheet, and writing the scale is mandatory, right? For angle, no need to write because it is already mentioned here. Here, sir, the one circle is of 0.04 magnitude. Okay, right here as such. Then the next thing is the angles which are represented in smaller size represents negative angles. Okay, you have to keep this also in your mind. Now we are going to plot each and every point from the table. The first point is at a magnitude of 2.11, I need an angle of minus 150 degree. Right. So here the magnitude is 2.11 and the angle is minus 149. So here you see this is my 2. Okay, magnitude circle 2. So 2.11, it lies around this part. Okay, in this circle represents 2.1. And the phase angle is minus 149. So this is my 140 and this is my 150. So here lies my 149 and this is my point number 1. Right. And the next point is 1.3 and phase angle is minus 159. So this is my 1.2 line. So here comes my 1.3. So what about the angle? The angle is minus 159. So here this is 150, here 160, right? So here comes my 159, right? Similarly, you have to mark each and every point on the polar sheet. I believe you people understand how to mark each and every points, right? So after marking all the points, just you have to connect all these points by using a free hand. So finally, I had drawn our polar plot. So this is the polar plot which you are getting for our problem, right? So for this polar plot, now we are going to calculate the gain margin and phase margin. Why? What is the necessity? Because we are asked to find the value of k, right, for different values of gain margin and phase margin. So it will be very useful. We can keep these values as reference values, right? So here now we are going to find the gain margin. So how to find the gain margin? The thing is, this polar plot is, this polar plot is intersecting our 180 degree line at some point, right? Just find out what is the magnitude. Here the magnitude is exactly 0.4. So here the gain margin is calculated by 1 divided by that particular magnitude value. So the magnitude is 0.44. So here, or you can keep 0.4, okay, nothing makes much difference. So here the answer is some 2.27, right? Then we are going to calculate the phase margin. So how to calculate the phase margin? The phase margin is calculated at the intersecting point of our polar plot with a unity circle. You see here, this is our intersecting point, right? Our polar plot gets intersecting with the unity circle. So at this point, exactly find out what is the angle. So here when you move, just you can know directly by gradually moving like this, or it is better to use a scale, right? Then it will give you more confidence. So here exactly when you look at this, the value is found to be around some 165, right? So here the phase margin is calculated using the formula, that is 180 degree plus pi gc. So here the angle is 165 degree, right? Again it is a negative angle. So minus 165 degree. So the answer is 15 degrees. So finally we had find out the values of gain margin as well as phase margin, right? So from the polar plot, when the value of k is equal to 1, the value of gain margin is, that is we have to take 1 divided by that value, and the answer is 2.27, right? Now we are going to find the gain margin in dB. So what is the formula? Again it is 20 log of this kg term. So 20 log of 2.27 is given by 7.12 dB, right? Then the thing is the value of phase margin is 15 degree. Okay, just now we had find out in our polar plot. The first thing is we are going into the problem. The thing is we are going to find the value of k when the gain margin is 20 decibel, right? So here the gain margin is 20 dB, it is given. So what is the formula for gain margin? The gain margin formula is 20 log of, you can write kg, okay, here this kg directly, or kg is nothing but 1 divided by that particular point, right? So it is given as 1 divided by g of j omega at pc. So here this 20 and this 20 cancel each other, and here we are getting the answer as equal to 1. So to remove log, we have to take antilog, right? So when you take, we are getting 10 to the power 1 is equal to 10 here. That is 1 divided by this term is equal to 10. Then what about this term? You have to take reciprocal. So when you take reciprocal, we are getting the answer as 0.1 here, right? So the thing is, we are going to find the value of k. So for finding the value of k, there is a formula which is nothing but GA by GB. GA is our new value, right? 0.1. And what is GB? Here GB is nothing but our old value. That is the value which we found by keeping the value of k as 1 here. So GB is 0.44. Just substitute the respective values here, and finally we are getting the value of k as 0.227. Right. For this value of k, the system gain margin will be equal to 20 decibel. Right. Now the second part of the problem is we have to find k when the phase margin is 30 degree. So what is the formula for phase margin? It is given by 180 degree plus pi gc2. So here that is pi gc, since we are having a earlier case pi gc1 when the value of k equal to 1, here I am naming it as pi gc2, right? Here just substitute the values. So 30 equal to 180 plus pi gc2, and pi gc2 is given as minus 150 degree. So here now we have to again move to our polar plot. So here where is our minus 150 degree? So here lies our minus 150 degree line, right? 150 degree line. So here this is our polar plot. So just from this minus 150 degree, just draw a line. It will meet our polar plot at some point. Okay, at this particular point, just note down the magnitude. See, so here it comes around 2, right? So this is our 2, and each line, each circle stands for 0.04. So this is nearer to 2, right? So here from the polar plot, the value of this magnitude circle is taken as 2.04. I am again insisting you that there is no need that you should always go with the book values, right? So here it is coming around 2. You can take 2, or even you can take 1.98, and here they have taken 2.04. okay, everything is same. It won't make much bigger difference. Okay, so don't get confused much. If you whatever value you are getting from the polar plot or polar sheet, just substitute directly. Anyhow the final answer will be the same, right? So here the value of GA is 2.04, and here what is our reference? We are comparing with our unity circle, right? So here the GB we are taking as 1. So K is nothing but GB by GA, which is nothing but 1 divided by 2.04, and here the value is 0.49, right? So finally the result is when the value of K is 1, we are having the phase margin as 15 degrees and gain margin as 2.27, right? And the second thing, for a gain margin of 20 dB, what is the value of K? It is 0.227. And for a phase margin of 30 degrees, the value of K is 0.49. Right. Here comes the end of the problem. Hope you people understand well. If you have any doubt, let me know in the comment section. Thank you.